Alright everyone, so after today's lesson I realized that I felt that I was going too fast, so I decided to create this video on domain and range. So let's go back to the example we left off in class today. So we have this graph, right, as you can see, and we're told to find the domain and range. As we went over in class, there are 5 ways to express the domain and range. You can express using words, number lines, list, set notation, and interval notation. And as we discussed, you only use lists to write the domain and range for discrete data. Since this is continuous, it's connected, we will not express domain and range using list. It's not possible. So in order to find the domain and range, step 1 is to figure out what your smallest x value is, your largest x value, that's for domain. The second step is to find out your range, the smallest y value, and the largest y value. So for domain, first step, find smallest x value. Second is find largest y value. Sorry, x value. Then for range, you find smallest y value, and then secondly you find largest y value. In order to find this, we use the pencil method as we discussed in class. Okay, in our pencil method, what happens is for the domain, let's look at the domain. So to find the smallest x value, you put your pencil, suppose my pink line is my pencil, you put it vertically on the negative side. Okay, we put that vertical line pencil right here like this. You put your, physically you can put it vertically like this. This is your pencil. To find the smallest x value, you put your pencil vertically right here on the negative side on the x-axis. Okay, then you keep on moving your pencil. Let's move it here. You ask yourself, does it touch the graph? No. Continue on. It does not touch the graph. Well, it touches the graph right here. As we can see. So, at this point, what is this point? This point is -2 and 3. So -2 is our x because it's on this side. So -2 would be our smallest x value. All right, so let's write that down here. So for domain, smallest x value is -2. Now we continue on moving our pencil, and then we ask yourself, when does our pencil stop hitting the graph? So we move now here. It's still touching. It's still touching. And the last time it stops touching here. After this point on, there's no movement. The graph does not, it stops right there. And this point is 3, 0. This is our largest x value. So our largest x value is our 3. So largest x value equals 3. All right. Then to find our y. So I'm going to just erase this. So now to find our range, the smallest y value and largest y value. Again, we use the pencil method, and now we put our pencil horizontally on the negative y side to find the smallest y value. So let's put it horizontally like this. So we ask ourselves, is it touching the graph? No. So keep on moving. It's not touching, and it touches right here at that 3, right? And this point is again 3, 0. So smallest y value, is 0. So we can write that down. For range, smallest.
Attention, any staff members in the building, there was a cell phone left in the second floor staff washroom. That's a cell phone in the second floor staff washroom. Thank you.
Sorry about the announcement. So then now, next step is largest y value. So continue on moving your pencil and seeing where it stops. So let's move on. It's still touching, and the last position it stops is at this point right here. And this point is -2 and 3. So the largest y value is 3. Okay, so now I'm going to just erase these lines so we can Okay, so after finding the smallest x, largest x, smallest y, and largest y, now you use the different ways to express domain and range. So let's look at domain and how to express it using words. So let's go with the domain. So domain. You always start off with all real numbers, and then you say between. So maybe memorize this wording. So all real numbers. So our smallest was -2 and our largest was 3. So our x values range between -2 and 3. Between -2 and 3. Now after this you put a comma, and now you have to tell which points are included and which points are not included. So in order to find out which points are included and which points are not included, you look at the circle. Open circle means not included. The point is not included. Colored circle, so closed, means included. Right? So let's look at our smallest x value was 0, right? No, sorry, our smallest x value was -2. So our smallest was -2, right here. So this point, right, is open. So this means -2, open circle, is not included. So we write down here all real numbers between -2 and 3, not including -2, because we had the open circle on the graph, right? As you can see, we had this -2 and it was open. Now our largest x value was 3, right? Right here. Right here. This is circle. This is a colored in, sorry. Right? 3 is colored in. When we have a closed circle, that means included. So this means 3 is included, right? So that means all real numbers between -2 and 3, not including -2, but including 3. That's how you would express the domain in words. Now let's look at range in words. Again, for range, same line. All real numbers between. That's for everything. All real numbers between. Now your numbers will change. So here, first we write the smallest y value, which was 0. And now you write your largest y value, which was 3. Now you check. Is 0 included or not included? Is 3 included or not included? So now I want you all to go to this graph and check. So we had smallest y value was 0. For this point right here, let's do purple. So for this point right here, this was our largest y value, right? This point is 3, 0, y is 0. It's a closed circle, it's colored in. This means 0 is included. So we'll write down including 0. Now our largest y value was right here, 3. This is an open circle. An open circle means not included. So all real numbers between 0 and 3, including 0 because it was a closed circle, but not including 3. It does not matter if you said not including 3 first and including 0 after. It doesn't matter. It's just you need to tell which one's included and which one's not included. Order does not matter here. So we can see that not included, 0 was included because it was colored. 3 was not included because it was open. And same thing for domain. We can see that -2 right here, -2 was not included because it was open circle, and 3 was included because it was colored circle. So that's how you express domain and range through words. Now let's look at domain and range through number lines. So for number lines, it's straightforward. For domain, again, we just draw our number line, and you can put your smallest x value on the left side, and you can put your largest x value on your right side. So our smallest x value was -2, and our largest x value was 3. So we put -2, and then we can put 3, right? So here goes smallest x value, and here goes largest x value. And now you put in your circles, and now depending on the graph which number was included and not included, you color them in. And as we saw here, -2, we can go back to the graph. -2 right here was open, so we leave it as is, open circle. But 3 over here was colored in, so we color that in. So we color it, and since all the domain is every number between here, we connect this like that. All right, and then we move on to range. So again, for range, we put, or on the left side, we put the smallest y value, which was 0, and on the right side, we put the largest y value, which was 3. And now you go back to your graph and you check which number was closed and which one was open. So 0 was closed, right? As you can see over here. So that means we're going to color it in. And 3 was open, so you leave it as is. So we do this. And then you connect these as is, like this. That's your number line. And now we have set notation. So for set notation, the domain goes like this. You do a curly bracket, you write x such that, now over here, you write down your smallest x value, which was -2, then you put the x, and then now you put your largest x value, and then you put x belongs to real numbers, and you close the bracket. All right? Now, over here, we need to fill in between the x's with our inequalities. Since x goes between -2 and 3, we have this. Right? Because x is between -2, so x is always bigger than -2, but it's always less than 3. But now you have to remember, under these inequality signs, you have this line. This means either greater than / less than or equal. If you have an open circle, you use this or this. If you had a colored circle, closed circle, you use this or this. You put that line underneath, right? Since we said -2 was open, it was not included, we leave it with no line. But since 3 was closed, that means it is included, we put this line underneath because it can equal 3 because 3 is included, but -2 is not included, so no line underneath here. Okay? And again, here goes your smallest x value, and here goes your largest x value. All right? Same thing with range. But now range means we're working with y, so y such that, right? And then you have your smallest y value, which was 0. Remember here, 0, right here. And then we had 3 as our largest. So then you put y and then 3, such that y belongs to real numbers. Okay, since our y values are between 0 and 3, that means every y value is bigger than 0, but less than 3. Okay, that makes sense. But now, was 0 included? Go back to your notes. Let's check. 0, look at this number line. It was included. It's colored. So when you have colored closed circle, we put this line underneath. Was 3 included? No. So we leave it as is. Again, over here, smallest y value and largest y value. That's domain and range for set notation. And now we have lastly interval notation. Domain, so you put your smallest x value here, and you put your largest, so the L stands for largest, S stands for smallest. Our smallest x value was -2 and our largest was 3. Then you have two options. You have hard brackets. Hard brackets mean included. Soft brackets, not included. -2, let's look at the set notation. -2 right here was not included because there's no line underneath the inequality, right? So not included. So then when we're not included, we put soft bracket beside it. 3 was included because we have the line underneath. Then we put a hard bracket beside the 3. Now for range, smallest y value, largest y value, we had 0 and 3. And we have largest y value. Again, 0 was included. Remember this line underneath? It was closed circle from the graph. When we look at this graph, it was closed, right? So then we put a hard bracket because it's closed. 3 was not included, no line, right there. So then you put a soft bracket beside it. So that's how you do domain and range for those types of expressions: set notation, interval notation, words, and number lines. So I'm going to do another example, which I did not get to do in class. Okay, first I'm going to draw this example out. This is 3. Okay, we have this as our graph. And we're told to find domain and range. So step 1 again, what's our smallest x value and what's our largest x value? So for domain, smallest x value and largest x value. So again, pencil method, I'll ask you all to do. So we use our pencil method, and on the negative side of the x, sorry. So on the negative side of your x-axis, so vertically, put your pencil like this, and you keep on moving your pencil until you hit the graph. So we keep on moving it, and as you move, you'll see you hit it at this point. At this point, right here, what point is that? This point is -1 and 0. So x, comma, y, right? That means our smallest x value is -1. All right? And let's keep on moving our pencil. So you guys can do this physically with your notebook. We're still touching, still touching, still touching, still touching. And over here, when we hit right here, at this point, and this point is what? 1, 0, right? X and Y. After this point, there's nothing. The graph stops right here, right? So that means our largest x value is +1. right? So basically with the pen method, what you want to do is you want to move from left to right to find the domain, to find the smallest x value. You start at the left side and you keep on moving, and when it hits the graph, you know that's your smallest x value. Continue on going, moving, and then when it hits the end part of the graph, that's your largest x value. So over here in this circle, you can see that there's no open or closed circle. But what this represents is that every number between -1 and 1 is our domain, including -1 and including 1. Right? So that means -1 and 1 are included. So our domain for set notation, so for interval notation, it'd be smallest value, -1 and 1. For set notation, we would write x such that -1 because they all belong. -1 and 1 belongs. In words, it would be all real numbers between -1 and 1, and you say inclusive when both are included. All right? And then number line, again, that's straightforward. You put the smallest value on the left side, largest value here. Circles, since both are included, because our circle captures -1 and 1 and all those numbers in between, we color it circled. Even though it doesn't show, we have to understand that those numbers are included. All right, that would be our domain. So let's look at range. Smallest y value. Again, use your pencil method. And now for this pencil method, you would be starting from the bottom of the y-axis. It's not hitting our graph, not hitting, and it hits right here. What point is that? This point is 0, -3. Y is -3. So smallest y value is -3. Okay, you keep on moving up, still touching, and it stops at this point. This point is 0, 3, yx, right? So largest y value is +3. Okay, so then our interval notation will look like smallest value, largest value. Set notation would be y such that -3, y3, and y belongs to all real numbers. And in words, it would be all real numbers between -3, smallest value, and 3, largest value. Since both of these are inclusive. Again, this implies same thing as we discussed before. All these values for the range are included. That means -3, -2, -1, 1, 0, and 3. Even though we don't have those circles to define that, it means that these are included. So when you're given an exam on a test with circle graphs, you're not going to be given open or closed circles. You just need to understand in an enclosed captured circle, that means those points are included. So inclusive, and then our number line will look like -3, 3. Again, they're colored because they're included. that's how our number line would look like. So this is a short video that I hope this makes more sense compared to the lesson we did in class today. And if it still doesn't, please, I'll be uploading some videos as well from YouTube that you all can watch. And if you have any questions, please feel free to send me a message on chats or email me.